Hi, in this video we are going to illustrate the so-called chaining procedure. So we have been talking about hash tables in the previous lectures, and we have come to the conclusion that okay, it is working fine, but sometimes the hash function is going to map the same item to the same array slot. This is called a collision. So let's see a concrete example that, for example, we would like to put the value 23 where the key is equal to apple. So basically the item is a key and value pair. We would like to insert it, so the hash function is going to transform the key into an array index, for example the index 0. Okay, we just have to insert the 23, which is the value, where the array index is 0. Okay, so far so good. Let's suppose the fact that we would like to insert an item where the key is the orange and the value is 45. Then the hash function is going to convert the orange into an array slot, and we come to the conclusion that it's going to generate the same index, for example 0. So we would like to insert a value where there's already one inserted in this position. Okay, no problem, we just have to create a linked list basically. So the 23 is going to point to the next item with the value 45. What if, for example, we would like to insert another item with the key strawberry and the value 100? We just have to transform the strawberry into an array index with the help of the hash function, and let's suppose the fact that it's going to return with the same array index. You may come to the conclusion that this is not a perfect hash function, and of course a perfect hash function is going to generate different array indices to different keys. But just for now, for demonstration purposes, let's suppose the fact that it's going to generate the same array index over and over again. Okay, it's not a problem because we know for certain that the 23 is already inserted in the array index 0 and the 45 as well. Okay, we just have to insert it and the 45 is going to point to the 100. Okay, so basically we create a linked list, and this is why I have mentioned that the worst case scenario is ordo n, so linear running time, because we can end up with a linked list if the hash function returns with the same value over and over again. Let's suppose the fact that the hash function returns the index 0 whenever we would like to use it. Then it's going to create a linked list, and searching in a linked list is going to take ordo n linear time complexity. Okay, so this is how we solve the put method with the help of chaining. What about getting an item? I would like to get the value where the key is equal to strawberry. We just have to use the hash function. The hash function is going to convert the string to the array index 0. Okay, but we have to consider every single item in this list, and we have to check that what's the value we are looking for. Okay, the array index is the same, but the key for this item, and this item differs, of course. So we have to iterate through this linked list, and we come to the conclusion that the 100 is the value we are looking for. So again, we have to iterate through a linked list. We end up with a linked list search, and instead of the ordo 1 constant time complexity, we have ordo n linear running time. So this is why it's very important to construct the hash function to be perfect in order to avoid collisions. But in the next video we are going to implement the chaining method together. Thanks for watching.